Dear students, in last lecture we have studied fifth application of derivative, that is increasing and decreasing functions. How we will check whether the function is increasing or decreasing by using the derivatives. So if f dash x is greater than 0, then the function is increasing function, and if f dash x less than 0, then the function is decreasing function. Now today very important application we are studying, that is the maxima and minima. Always there is the example on this maxima and minima in board exams, also in CET exams, JEE exams, and also this article is useful when we are studying engineering mathematics. Also in engineering subjects, this concept we are using in applied mechanics, in strength of material, in electrical engineering, etc. So here, from this name we only will get maxima means maximum value of the function, minima means minimum value of the function. So if we suppose draw the graph of this function y is equal to f of x, for this function suppose at x is equal to a maximum value, and at this point if we draw the tangent to this curve, that tangent is coming parallel to the x-axis, that is the slope of tangent is 0. So you know the slope means tan psi, psi is the inclination of the tangent. So as the tangent is parallel to x-axis, the slope is 0. So we get for maximum dy by dx, that is f dash x is 0. Now if we consider neighborhood interval, suppose a minus h to a plus h, h is very small positive number. So in a minus h to a interval, if we draw the tangent to the curve, that tangent makes acute angle. Now as the tangent makes acute angle, so to the left of a, f of x is increasing. F dash x will get positive, is increasing. F of x increases, and to right of a, f of x, now tangent makes obtuse angle, negative value, so f of x is f of x decreases. So for maximum, that is x is equal to a, f of a is maximum, f of a is maximum, f of x is maximum if to left of a, f of x increases, and to right of a, f of x decreases. Or we can say in a minus h less than x less than a, f of x increases, and in a less than x less than a plus h, f of x decreases. H is very small positive number. Similarly, for minima, that is what when we will get the minimum value of the function. So at minimum also, if we draw the tangent to the curve, the tangent is coming parallel to the x-axis, and slope of tangent 0, meaning of that dy by dx, f dash x is equal to, we get 0. And if we consider neighborhood a minus h, a plus h, h is very small positive number. So to the left of this a, if we draw the tangent in this neighborhood, the tangent makes obtuse angle. So negative value is coming, means decreases. So f of A is minimum. F of A is minimum if to left of A, f of x decreases, and to right of A, f of x increases. That is, in interval a minus h less than x less than a, f of x decreases, and in interval a less than x less than a plus h, f of x increases. Here also h is very small positive number. Very small positive number. Now here, to study this maxima and minima, we are using two methods. One is the first derivatives test and second is the second derivatives test. So we'll study this. Methods to study maxima and minima of function. So first derivative test. This is used to find local maxima and local minima. So to study this local maxima, local minima, we use the first table. So what is this first derivative test? So if f of x is maximum at x is equal to, suppose, a. You can consider a, c, any point. So f of x is maximum at x is equal to a if first condition f dash a equal to 0 and tangent is parallel to the x-axis. Second condition, f dash a minus h. So for maximum, you know the tangent is greater than 0. F dash a plus h. So you keep the graph in the mind, increasing, decreasing functions. So write this obtuse angle less than 0. And f of x is minimum at x is equal to a if first condition f dash a equal to 0. Second condition f dash a minus h less than 0, decreasing function left on the left side. So and f dash a plus h to the right of a, increasing function, so greater than 0. So with the help of these three conditions, we can check whether the function will get the maximum or minimum, that is local maximum or local minimum values. Now if f of a minus h less than 0 and f of a plus h also less than 0, or f of a plus h greater than 0 and f of a minus h greater than 0 and f of a plus h also greater than 0, then f of a is not maximum or minimum, that is not maximum or minimum value, and point x is equal to a is point of inflection or saddle point. Point of inflection or saddle point. So in short, actually we plot the graph for that saddle point. Suppose a minus h, a plus h, graph is suppose coming like this. So here this point O is the saddle point. Saddle or point of inflection, x is equal to 0 is saddle point, or a point we will consider. X is equal to a is point of inflection. Now here the term local maximum, local minimum. What is that local maximum and local minima? That also we understood here. So suppose sometimes we'll get, suppose if we plot the graph of the curve is coming like this. Now here we are if we draw the tangents at different points, we are getting the tangents parallel to the x-axis. So here we get the maximum value here, also the minimum value here, maximum. So this value is not maximum, but in the graph at that point it is maximum. So this is called local maximum. Local maximum. This is the actual maximum. This is called stationary value. Or extreme value. Now here this is local minima. Local minima, because then this value, this is the maximum and this is the actual minima. Actual minima, and this is the stationary or extreme value. So when they are asking find stationary values or extreme values of the function, so you want to find this perfect maximum and perfect minimum values of the function. So this is the concept of the local maximum, local minima, and the method to study this local maximum, local minima by using the first derivatives test. Now we will take one example for this local minimum, local maximum. We'll take example for this local maxima and minima of the function. So we have what x equal to 6 upon x square plus 2. So you know this for maxima, that is, or we can say the function is maximum and x is equal to a, if f dash a is equal to 0 and f dash a minus h is greater than 0, f dash a plus h less than 0, then the function is maximum and formula. So here to recall the formula, you want to recall increasing, decreasing, and for that you recall the graph, maximum graph, minimum graph, tangents, acute angle or obtuse angle. Acute angle positive value, obtuse angle negative value. So we want to first find f dash x. So solution, f of x equal to 6 divided by x square plus 2. So f dash x equal to minus 6 upon x square plus 2 bracket square into derivatives of x square plus 2 is 2x. So that is equal to minus 12x divided by x square plus 2 bracket square. So for maxima or minima, f dash x equal to 0, tangent parallel to the x-axis. So minus 12x upon x square plus 2 bracket square is equal to 0. So x is equal to 0. So this is the point on the curve at which we'll check whether at this point the function is local maximum or local minimum. So this is a is equal to 0 in short. Now we'll find f dash a minus h means f dash 0 minus h. H is positive number. So if you put this value in this derivatives, so minus 12h divided by minus h, minus 12, x is equal to 0 minus h, we are, that is minus h, minus h divided by minus h square, so it becomes positive h square plus 2. So we have that minus h, we are getting. Now this minus minus plus, so 12h divided by h square plus 2. So greater than 0. H is positive, h square is always positive, so greater than 0. Meaning of that, to the left of a increasing function, left of 0, f increases. And f dash a plus h, that is f dash, put x is equal to a plus h, so 0 plus h, that is f dash h equal to minus 12 into h divided by h square plus 2 square of that. Now this is always positive value, so less than 0. That is right of 0, f negative means obtuse angle decreases. So therefore f of x is local maxima at x is equal to 0 and f max x is f of 0, so that is equal to, put value in the function, so 6 upon 0 square plus 2, so that is 3. So this 3 is the local maximum value. So minimum value is not available for this function.